C++, I almost said Java. It's what you would expect it to be. It's a sequence of characters, which is a different type. This is a primitive type. We're going to call this the name of the method multiplied by 2. And then the first thing we're going to put in our stack frame are all the parameters, which just one in this case, assigned to the values of the arguments. So we're going to have a parameter input assigned the value num2. I have to resolve num2 to a value. This is in the main stack frame. I'm resolving num2. So I look in the main.
Hold. Right, let's do this. Thickless, what's up? Okay. Imposter sus, what up? Gotta readjust. Of course, my dog barks as soon as lecture starts. Why wouldn't he? Alright, so let's get started. Let's do 116 CS2. So you saw my welcome email, I assume. But I'll reiterate some of the things in that email. One thing is there are 2 lectures each day, one from 8 a.m. to 10:30, which just ended half an hour ago, and now I have to reset my brain back to the beginning of lecture for the 11 a.m. lecture. This one that goes until 1:30 p.m. all times Eastern Standard Time. So if I seem like a mess at the beginning of lectures, like right now, that's because I just lectured for 2.5 hours, had a half-hour break, which goes way too quick, and now I'm right back at it again. So, all right, back in lecture mode. Let's do this. So this is the Summer 2025 Computer Science 2, and let's just start going through the links. I'll try to keep this brief and not spend forever just reading the syllabus to you, but that took an hour and 5 minutes in the morning lecture, so I'm not very good at keeping it brief. There's just a lot of stuff that I've got to say, and a lot of stuff to get you introduced to the course. So let's get into it. So watching lecture. Oh, and I always forget to introduce myself, so let me do that one first. I'm Dr. Jesse Hartloff. I just go by Jesse. We can keep it casual. If you like the formality, doctor, professor, that's fine too, or any other titles. But we can just keep it casual. Just call me Jesse. If you come in office hours and say, "Yo, Jesse, what's up?" It's fine. It's perfectly. That's what I prefer. But everything else is fine too. It's not that big of a deal. But we can keep it casual. I'm not one of those "you must call me Dr. Hartloff" or any of that crap. We don't play those games. So first one, watch lectures on YouTube. If you're hearing my voice right now, you already found this link and you figured that one out. You know what that's about. But there's still one thing I want to say about this, is if you go to the channel and look at all the lives, you notice that there are lots of videos here. I've been using this YouTube channel for a while. There are 2 previous summer courses here worth of videos. So you can go back and watch the previous videos. If you watch them from last summer, the content has not changed very much or, at all. Very little changes. There are a few slides. I'm trying to get my bearings here. There are a few slides that'll update over time, just small changes, but the content is the same. The concepts are all the same. It's going to be the same material. So if you go back to this lecture 1, well, I guess technically the 11 a.m. if you want to watch this one. But these 2 lectures are the 2 lectures that I did a year ago for summer 24. So if you want to get ahead on things, you can always watch these lectures. This lecture 2 is what I'm going to talk about on Thursday. Basically the same thing that I'm going to do this Thursday. Lecture 3 is next Tuesday, etc. All the way to the last lecture. And yes, you're seeing that right. There are only 10 lectures in the summer. Everything is condensed into 10 2.5-hour long lectures, with the exception of the midterm. One of these is shorter. One of them is only an hour because we have the midterm exam that day, and we just clean up files. Files doesn't take too long, so I just cram that in 1 hour that day. So we're going to cover 10% of the course today, if you want to look at it that way. It's wild. Summer goes fast. I said that multiple times in my intro email. It goes fast. I'll say it a bunch more today, and then I'll try to not say it too much throughout the semester because you'll get the point after today. But 10 lectures. If you want to get ahead, since summer does go so fast, one of the things you can do is watch these old lectures, watch the previous lectures, and get as far ahead as you want in the course. You could watch them, well, I haven't added up all the times, but you could watch them all this week and get all of the content that you want. Or you can watch the live lectures, watch them as they come. I'm still going to record them live, as much as I could just say, go watch the old lectures, see you later. I'm still going to lecture twice each lecture day over the summer and do live lectures, mostly for the live chat, partly because I I don't know. I don't know how the university would look at that if I just said, go watch my old videos. But the reason I want to do it is because we get the live chat. You can have interactions. You can ask questions during chat or during lecture. I think that's a very valuable part of why we still do live lectures and not just record them once and post them, because we do have the technology to do that these days. But live lectures, so you can ask questions and interact, is I think an important part of the education process. Next, I'm just going to go through all these links. Next is in Autolab. If you've taken 115, I'll say that a lot this lecture. If you've taken 115 at UB, you know what this is all about, but I know that not all of you have. So if you're not from UB, if you're just taking this as the summer course from other universities or wherever or wherever, however you got here, you might not have seen Autolab before. So I just want to give a brief tutorial of it. Autolab is where we're going to submit the programming assignments. There are 8 of them throughout the semester. They are all live on Autolab, ready to submit. When you submit a programming task, you're going to submit it as a zip file. You'll click this, choose your file, tell me that you didn't cheat, and then click submit. I can't click submit because I didn't actually choose a file. And when you do submit, it's going to auto grade your submission. It usually should take 10 seconds or so. And when you'll get feedback like this, it'll show you all the files in your zip file, so you can verify that you submitted the proper zip file, that everything worked in that sense. And then it'll give you feedback on how well your submission did, whether it passed all my tests or not, whether your tests are thorough enough or not. And if you pass all of the checks for this autograder, you'll get a 1 for complete, meaning you are done with that programming test. You're done with that. If you didn't complete it, you'll get a 0 here, and you can use the feedback to work on your submission more and then submit again. And the important point here, one of the important points, is that you get unlimited submissions. So you can submit as many times as you want before the deadline and get your feedback and revise based on that feedback. Submit again, get your feedback, submit again, get your feedback, and keep submitting as you're working on the assignment. So I always get, there's sometimes a student, first time they see an Autolab and they think it's one and done. You just submit once, and if you get a 0 on the assignment, you're just done. That's not the way it works. You get unlimited submissions, as it says right here, unlimited submissions left. So you can submit as many times as you want. So there's no harm in submitting early and submitting often. There's no harm in that. I do recommend not abusing that sit down and really think about your submission before submitting it and not just using it as a guess and check tool. But at the same time, there's no penalty in the course for using it as a guess and check tool. As much as I don't like seeing it because I think you learn less doing it that way, you can still do that, especially if there's one piece of feedback in Autolab that just doesn't quite, you're just not quite understanding what it's meaning. Sometimes you do have to devolve into guess and check mode. But unlimited submissions is my key point there. GitHub, this is where all of the lecture examples that I cover are going to be. Any examples that you see in the slides, go to this repo, go to source, and you're going to see all these directories with week 1, week 2, etc. This is set up for the structure of a fall or spring semester, but in the summer, if you just read week as lecture, this is lecture 1, this is what I'll cover. Lecture 2, this is what I'll cover, roughly at least. That's about going to pan out that way. That's the way the summer is structured. Each lecture is an entire week of content from the fall and spring. So you can see all the code, like this Hello World example. This is the first example we're going to look at today. And you can see the code right here. So to reference any of those lecture examples, get your hands on them and start playing with those examples. They're all right here for you. Everything that I'll show in lecture. A memory diagram tracing tool. If you haven't seen tracing, if you haven't seen this before, again, if you haven't taken 115 at UB, you're going to start getting familiar with this. Starting today, this is the example that we'll go through today, actually, which I'm going to delete right now. And you know what? Don't ask me again. And this is the tool that we'll use to trace through code. If you've never heard of that before, one, like I said, you're gonna get a good dose of it today and pretty much every lecture, possibly every lecture. And what we'll have Java code here, and what we'll do is trace through everything that happens in memory, in both stack and heap memory, and everything that's printed to the screen as that program executes. And this, I'll use it a lot during lecture, and this is also how you'll take your quizzes. I use the words quiz, midterm, and final. I'll explain what all that entails when I get to the grading portion. But when you do those, you're going to use this tool to do them. So I want to use this tool during lecture to show you exactly what I expected to do on those quizzes, on those exams. So we'll use this extensively. There's the memory diagram reference, which is going through, I think, all of the concepts that we cover in the course and how to use them in the tool. Has sample traces. Here's some code. And here's exactly what the trace for that code should look like in the tracing tool when it's complete. So lots of examples, lots of resources to be able to learn how your tracing should work, and it definitely an excellent resource for studying for the midterm and final exam. Piazza, ask questions and find office hours. So if you click on that, it'll take you right to the office hour schedule post where we're going to post office hours. I don't have more to say about that. Actually, I do have a lot more to say about that. So this is the office hour post. First, let me talk about Piazza before I forget. If you haven't seen Piazza before, this is where you can ask questions asynchronously. So ask a question, then me and the two TAs, we have two TAs, Matthew and Miriam, who will answer your questions. When you create a post, if you're creating a post that contains any of your code or sensitive information about your grades or anything, make sure you click individual students instructors and then select instructors to make a private post to instructors for that question. If it's something that everybody in the class, it doesn't have any sensitive information about you, none of your code, none of your grades, none of that, you can post to the entire class if it's something that everybody can benefit from the answer. Like the public posts that have been posted already, they've pertained to everybody in the class, so make it public so everybody can benefit from the answer. I'm not going to click on any of these because I don't want to dox anyone, but but you can make those public posts as long as they don't contain code. If you're posting your code publicly to the whole course, your solution to a task, it's a pretty obvious academic integrity concern, so just please be careful about that. Office hours are all going to be on Zoom in this meeting. So when it's office hour time, you click this meeting, it'll take you right to the Zoom meeting. And I know I'm basically just going to read this line for you, but this is important. I want to make sure everybody knows this because I've had problems with this in the past. When you go, the way we're going to use office hours is we're going to be in breakout rooms, and then we're going to invite students into the breakout rooms when it's their turn when we're ready for them to see help. So when you join the meeting, you'll be in the main room and we'll be in a breakout room. And it might look like that you're in the meeting by yourself, which isn't going to be the case. What's likely going to be the case is that you'll join, say there's only 2 students taking advantage of office hours. You join the meeting, you're going to be in the main room by yourself, and it looks like you're just in an empty meeting and nothing's happening. But what's happening is that we're in a breakout room with the other student helping them. And then once we're done helping that student, we'll invite you in the room, into our breakout room, so you can ask your questions and get some help. So please be patient. If it looks like you're in an empty meeting, you're not. Just be patient. Wait for us to invite you into the breakout room, which might be, it could be 10, 15 minutes if we're helping another student and getting them through the assignments. It could be a while. So just please be patient and wait for your turn at the front of the queue. And double check the office hour schedule. If our name's on the schedule at that time, you show up to office hours at 2:05. I'm probably already going to be in my breakout room with another student. So just be patient, wait for your turn, and And that's what I was saying. If my name's on the schedule, like I'm gonna be there. If Matthew's name is on the schedule, he's gonna be there. If we do have to cancel, we'll either remove our name from the schedule, or if it's just a temporary cancellation, we're gonna cross out our name to indicate that we got sick, or whatever happened, we had to cancel that office hour. And I'll be on my TAs making sure that they're up to date with that. So if our name is on the schedule and it's not crossed out, like Matthew will be there tomorrow at 10 a.m. He'll be in this meeting in a breakout room waiting, waiting to answer your questions. So don't just leave the room. I don't want to see somebody leave the room without getting their questions answered. When we are there and maintaining the queue, we'll be keeping an eye on the main channel and maintaining a queue on our own to see who was there first, to know who to invite and, in which order. So just be patient. Don't leave the room without getting your question answered. And Miriam will add her office hours. Hopefully she can fill in this block of time Wednesday, Friday afternoons. When I talk about deadlines, I'll expand on that a little. And Discord, I won't click on this one. But Discord, I've been using the same Discord server for quite a while since COVID. So there are a lot of students, who have already taken 116, a lot of alumni of UB, just a lot of people in there. If you have questions about the course, about the program, about computer science, about industry and the job market right now, which, spoilers, it's not super great right now. But if you have questions about any of that stuff, there's tons of people in there who would love to just chat about it. If you have a 116 question, go to the 116 channel and chat, and feel free to take advantage of that resource and take advantage of all them people there. During the fall and spring semester, I usually use this during lecture. I have a lecture channel on the server so students can ask questions during live lectures. It's not really relevant in the summer semesters because I have YouTube chat. I got chat right over here. If I'm looking over here, that's me looking at chat, glancing over there. So we really don't need Discord chat during lectures when we have live YouTube chat. All right. And like I said, ask questions in chat. If you got questions, ask away. Right now I'm just basically reading the syllabus to you, so if there are questions, please ask them. If it's silent here, I'll just assume that you're sitting there going, why the hell is he reading the syllabus to us? But let's keep going through the syllabus. There are a few things, key points that I want to make sure I hit. So my tagline for this course is how to write large programs. In 115, you already learned how to program, and you already learned how to program, so now 116 focuses on how to write large programs with a focus on unit testing, OP, and data structures are 3 core pieces of the course. How do labs work? So lab is just going to be treated like lecture. So on the schedule, you have 11, I forget even when the times are, 11 to some time, then a 10-minute gap, and then something until 1:40. I'm treating that as one big 2.5-hour lecture. So I skip the 10-minute break and then end 10 minutes earlier. So from 11 to 1:30, 11 a.m. to 1:30 p.m., all Eastern Standard Time. That'll be just one big lecture time. We don't have the time to do a typical lab like you would see in a fall or spring semester, where each week we have 2.5 hours, actually 2 hours and 40 minutes of lecture, plus a 2-hour lab in 14 of those weeks. In the summer, we have 11 lectures that are each 2.5 hours long. So there's just significantly less time to cover everything. So there's no traditional lab like you would expect from a fall and spring. I just want to make sure, but the 2 quizzes in the midterm are just going to be tracing. Yes, they are both tracing. Yep. And there are no, again, if you are familiar with a fall or spring semester, there are no interviews. Again, just no time. We have 6 weeks to cover everything for this course. Some things just have to get cut. Some of you probably aren't complaining about that. But some things, unfortunately, do just have to get cut to fit everything in this very, very abbreviated time frame and very little lecture time, and only 2 TAs instead of 44 that I had last semester, we have 2. It's a very different environment, very, very different from the fall and spring semesters. So is the same live stream as this one? Yep, this live stream is just going to go until 1:30. And if you want that break, if you're like, hey, I have a scheduled 10-minute break there, and I want a 10-minute break, just pause the stream. You won't, you'll lose live chat, but you can just pause the stream and be 10 minutes behind for the rest of it. It's not a big deal. Usually I do a vote. I used to do a vote where the first lecture I'd say who wants the 10-minute break and who wants to just run through and end 10 minutes early, and it's always at least mostly unanimous voting for going through the break. So now I stop giving the option and just do that by default. So yeah, it's just a 2.5 hour lecture and no typical lab. If we actually treated that as a lab, there would be a 0% chance that I could get through all of the lecture content. There just simply wouldn't be enough time. It would never happen. So it's treated as one big lecture. But officially, for it to be a 4-credit course on paper, it does have to be a lecture and a lab, is I think the reason they schedule it like that. How much expected time we should allocate for a task? 12 hours per lecture. This is my estimate. I think this is pretty accurate, but that base roughly works out to 9, 10, 11-ish if you do all the math and average it out. About 10 to 11, maybe 12 hours per task times the 8 tasks is should be. I just did the math for the other lecture. Should be 150 hours. Yeah, 150 hours total for the course over 6 weeks. Which actually, that's the part of the syllabus I'm at right now. So let me talk about that right now. So it's a 4-credit course. They usually say 12 hours per week for a 4-credit course. That's over a 14-week semester. We have a 6-week semester, so it roughly translates into 12 hours per lecture instead. I have a little typo. This should say lecture as well. I got to fix that because somebody might be like, 9 hours a week. That ain't too bad. This should say 9 hours per lecture because 12 hours per lecture, but 2.5 of those hours is just lecture itself. So 9.5, I didn't feel like putting 9.5 here. So 9 hours per lecture outside of class for a total of 24 hours per week on 116. So for 6 weeks, you should be thinking 116 is the thing that I do for 6 weeks. I mean, not fully. It's not even a 40-hour full-time work schedule, but it is something you got to take seriously. 24 hours per week, basically a half-time job to complete 116. That's what I would expect as a minimum to do well in the course. That's what you should be ready to invest. That's the time commitment you should be ready to put into this course. Some students will say it's way more. Some students will say it's way less. So I'm trying to average across all students. This is about what I think the average is for this. And you should want to learn. I just assume that you took a course in computer science and said, yeah, I'll take a second course in computer science. That wasn't so bad. I'll do it again. So I assume you actually want to be here. Not an assumption I make when I teach our CS1 or 115. But 116, yeah, you want to be here at this point. And understand the basics of programming, which goes back to our 12 hours per lecture. Understanding the basics of programming is something I expect coming from 115 or wherever you came from for your CS1 course. I expect you to understand the concepts of those basics, those fundamentals that you learned, which would include variables, functions, expressions, statements. I think is how they divvy those up in 115, statements versus expressions. Now I'm thinking about that and lost my train of thought. Conditionals, which are your if statements, if, else if, else. Loops, data structures, including a sequential data structure and a key value store. In Python, that's your list and dictionary. And I think that's it. And a little bit of file reading we're going to do later in the semester. But if you didn't get file reading and you save that for later, as long as you're up to speed on everything else by the time we get there, You'll be all right with that. But definitely the fundamentals of programming, variables, functions, loops, conditionals, data structures. You should be a pro at all of those things. If you are not, that's where this 12 hours per lecture goes way up. So that 12 hours assumes that you're already on track with everything, and it's an average across the semester. So there will be a temptation for you to not do very much this week, for example. Maybe you just go to lecture and put in 5 hours this week instead of 24. Those extra 19 hours are going to catch up. It just means you have more work to do next week or the week after once the deadlines start coming. If that first deadline for task 1 takes you 50 hours, don't be too surprised because you didn't study this week. Like this week you should be getting familiar with Java, writing some basic Java code, some basic programs, and making sure you understand how to do everything from 115 in Java. And if you were shaky on 115 topics or you didn't or you haven't thought about any 115 topics since you took 115, whenever that was, even if it was just last semester. If you took the final exam, just dumped all that information out of your brain, or there's a lot of situations. Or if you just squeaked by with a C in 115, you're already behind. You need to play catch up right now. So that 12 hours per lecture is going to go way up because you have to invest that time that you didn't spend learning 115 thoroughly. If you didn't crush 115 with an A, you were behind at the end of that semester. And if you didn't study over any breaks, after the final exam, if you didn't study to fill in your gaps, you're already behind and you should be spending more than 12 hours per lecture. And my goodness, good luck to you, because in a 6-week summer course, when you don't understand 115, I'm sorry, but I just don't see that happening. I see you retaking 116 next semester. But prove me wrong. I would love to see you prove me wrong. But I just want to make sure that the expectation is set that this is no joke. The course is tough in the fall and spring semesters when students have 14 weeks, full weeks to do the whole course. So to crunch that into 6 weeks, it's intense. It's intense. Don't fall behind. You expect to stay up to date with everything too. Hopefully, I'll emphasize this a few more times, but I probably already made the point abundantly clear. All right, so let's talk about how the course is graded. And this is a bit different. It takes a while to go through the grading structure because this is a different type of grading style than you're probably used to. If you've ever taken a course with a grading structure like this uses what's called mastery-based learning. If you've ever taken a course that is like this, I would like to know about it because I like to reach out to your other instructors and kind of compare notes and just share ideas. But this is mastery-based learning. It's big. It's becoming more relevant in the academic research world, but it's hopefully starting to become more popular in practice. But anyway, what this is there are learning objectives of the course, and you must complete every learning objective of the course in order to pass the course. So I'll skip all the reasoning of why and everything. If you're interested, you can ask me in office hours. I'll talk for hours about it. But you have to complete all of the learning objectives of the course. And for the summer, what this pertains to is being able to read and write code that uses the core concepts of the course. You need to be able to read and write code using the concepts of classes, inheritance, polymorphism, linked list, trees, and graphs. With one notable omission, reading for graphs is not there. I'm not going to give you any tracing quiz for graphs. So for reading, what you'll do is you'll go into the tracing tool. I'll give you a code that uses the concepts that assesses the learning objectives, all these concepts, and you have to trace through that code. And if you trace through the code successfully, then you've completed that learning objective. For write, it's more straightforward. Write, that's the programming test, the 8 programming tests. Complete those, write the code, get checked off for those. Those are the learning objectives. Oh yeah, and how they're assessed. And you need to complete there's 8 programming tasks and 2 what I'm calling quizzes, but the wording, the naming gets a little muddled here, and I'll explain it. I'll take a while to go through this section. Let me explain the easy stuff to explain first. So you complete all of these, and then your grade is going to depend on the application objectives, which I'll explain in a minute. If you don't complete every learning objective of the course, that's an F in the course. You do have to complete all of these, every one of these. So there's 8 programming tests. That one's pretty clean. Autolab has to give you a 1.0 on each of the 8 programming tasks. Once that happens, Autolab says you're good, I'll say you're good, and you're good. And then the quizzes takes more explanation. So there's 2 quiz requirements: object-oriented programming and data structures. And these quizzes are divided between a midterm and a final exam. So I'm kind of mixing the terms exam and quiz here. Quizzes, there are no exams in the fall and spring semester. I just have a bunch of smaller quizzes. We don't really have time to have a whole bunch of little quizzes. So I group the quizzes into the midterm and final in the summer. But you can think of the midterm as an OOP quiz and a data structures quiz stapled together, and then that's your midterm. And then the final exam is the same thing. It's an OOP quiz and a data structures quiz that you take both of them, and then that's the final exam. The structure of the midterm and final exam will both be exactly the same. Obviously, the questions will be different, but the structure is exactly the same. And that structure is 2 OOP traces. Every quiz is a trace. In the tracing tool, you get the code, you trace through it, you submit it. I gave a tutorial in the last one somebody asked, so let me do one here. You'll get like a Java base. We don't have a Java basics quiz. This was just a practice quiz last time. You'll say you won't see this because I already started it in the previous lecture. Let me just do one where that's not the case. You'll get this. At the start of an exam, I'll email you the links to all of the quizzes, all the traces. You'll say, yep, I'm ready to start. You'll get the code here, and then you'll go through your trace. Once you're done with the trace, you'll click review. You'll have one last chance to look over all your work before submitting, and you submit. And now that's in my grading pile, and it's ready to be graded. So that's the logistics of the quiz. So you get 4 of those, 2 OOP and 2 data structures traces, which the 2 traces combined I call a quiz. So an OOP quiz and a data structures quiz, each with 2 traces each. So 4 traces for the midterm. I'll email you 4 links. You'll do those 4 traces, submit all 4 of them, and then wait for your grade. To complete the learning objective, you have to complete the OP learning objective and the data structures learning objective. You need to complete 1 trace for each of them. So 1 OOP trace and 1 data structures trace to complete the learning objective. So if you take the midterm and you get 1 of the OOP traces but fail the other one, and you get 1 of the data structures traces and fail the other one, and all traces, by the way, are graded on pass-fail. So if you get 1 out of each category, then you've completed both learning objectives. And since you've already completed the learning objectives, guess what you do on the day of the final? Nothing. You don't need to take the final. If you pass at least 1 of each of them on the midterm, you don't take the final. So there's already a strong incentive to study for the final, study for the midterm, do well on the midterm, and then just skip final. July 3rd, there's nothing. I'll have nothing for you. Your semester ends on July 1st instead. So if you don't pass 1 of each, so for example, say you get both the OOP traces, you studied OOP really thoroughly, you get both OOP traces, and then on the data structures quiz, you fail both of the data structures quizzes. You haven't completed the learning objective yet. You have to complete it to pass the class. So I do give you 1 more chance. That's where the final exam comes in. Final exam is your last chance to complete these learning objectives. In that scenario, you would go to the final exam. There's going to be another 2 OOP traces and another 2 data structures traces. And you need to complete 1 of them, whatever you still need to be able to pass the class. So in that scenario where you already had 1 or 2 of the OP traces from the midterm. When you go to the final, you're going to ignore the OP traces because you already completed that learning objective, but you will do the data structures traces, and you have to complete one of them in order to pass the class, to complete the learning objective. So for each of the quiz learning objectives, you have 4 total traces. There are 8 total traces throughout the semester, 4 OP and 4 data structures. Out of the 4 OP traces, you need to complete 1. So out of 4 chances, you have to pass it 1 time to pass the class. And data structures, out of the 4 data structures traces, you need to complete 1 of them successfully in order to pass the class. So you get 4 opportunities. The grading structure is, I do understand the grading structure is very harsh on the surface and at first glance. Like right now, if this is your first time seeing this type of grading structure, you should be thinking, holy crap, this is ridiculously strict. And in a sense it is. I'm not gonna sugarcoat that one. But I do like to give you as many opportunities as I can for you to complete these objectives. The final exam is really my last opportunity to give you another chance, that last lecture, that last day of class. That's my last chance to give you opportunities here, so I'm going to take that chance and give you that one last chance. And for the programming tests, we'll talk about that when we get to application objectives, how I give you more time to work on those. Okay, so that's the learning objectives. You need to do this to pass the class, the 10 learning objectives. Again, if you're coming, I'll try not to mention this fall and spring too much, but if you're from fall and spring, even this is a little softer than fall and spring. We don't have interviews. There are fewer quizzes. The quiz grading is more generous. You only have to get 1 out of 4 quizzes. Like that's a 25% if you want to look at it as a percentage-based comparison to percentage-based grading. Yeah, you got to get a 25% on your quizzes to pass the class. Not asking too much. But the reason, and I won't go too deep into the reasoning, but just briefly, the reason is so you actually complete all the learning objectives. Like it's spelled out pretty straightforward in the structure, but if it's a percentage-based grading where like homework is some percentage of your grade, quizzes are some percentage of your grade, it's participation is some percentage of your grade, it's easy to miss a whole learning objective and still pass the class. What I want is no gaps in your knowledge. I need you to understand every concept, at least at some competency, to be able to move on to 220 and 250. Because if you skip an entire topic, say you didn't really understand trees, but you just took the L and passed with a B, when you get to trees in 250 and you don't have the background knowledge, any background knowledge on trees, it's going to be really hard for you to talk about self-balancing trees, self-balancing binary search trees, when you didn't even understand the structure of a regular old binary tree. It's going to be tough, and you'd likely just fail 250 if I let you do that. So I'm trying to set you up to succeed in your future classes with this structure. But that's the end. I won't talk any more about the theory of it. But that's a snippet of the theory. So once you complete all of your learning objectives, your grade will depend on your application objectives, of which there are 12. Get at least 10 of them, you get an A. You do need at least 3 to pass the class. So learning objectives plus a couple application objectives to pass the class. Application objectives are meant to be pretty free. There's nothing more, like I already talked about all of the assessment of the entire course. There's nothing new, nothing extra that you have to do, at least in this summer session. There's nothing extra that you have to do to get all of the application objectives of the course. You just have to do the things that you already have to do, but in a timely manner. So what I use the application objectives for is to motivate you to stay on track. You cannot fall behind in the summer. Falling behind by a single lecture is the same as falling behind an entire week in a fall or spring semester. Falling behind by 1 lecture is a pretty sure way to fail the class. Don't do it. Just don't do it. Don't fall behind. Stay up to date on the lectures. Either watch them all live, or if for whatever reason you can't watch them live, at least watch them the day of the lecture. Even that is really pushing it. That's really starting to get into some spotty territory. Or preferably, watch the old lectures from last summer, since I have that available for you. Take advantage of that and actually get ahead on the lectures as much as you can. would be my recommended strat. And I'll actually have a recommended strat I'll go through when we get through all of this stuff. So how do you earn application objectives? Well, just do what you're supposed to do when you're supposed to do it. Pretty simple. So let's talk about the details of what that means. For each of the 8 programming tasks, there are 2 deadlines, the expected deadline and final deadline. The expected deadline, as the name implies, is when I would expect you to complete the assignment. And that expected deadline, just to put some numbers on how fast the summer goes, is 2 days after the material for that task was covered in lecture. It means it's less than 48 hours to complete that assignment if you're watching the lecture live. It's 2 days from the start of the lecture when it was covered. And the intent here is that you're expected to complete the assignment before the next lecture starts, because the next lecture is going to introduce the material for the next assignment. And if you're still working on the previous assignment, when I'm covering the next assignment and you're expected to do the next assignment, you're falling really far behind at that point. I want you to go into each lecture with a clean slate, already done with the previous task, and ready to start learning how to do the next one. Not half paying attention in lecture because you're still thinking about the previous assignment, because you're still working on the previous assignment. So you don't have time to think about inheritance because you're still thinking about linked lists because you're still doing task 3. And when I'm teaching you how to do task 4, there's a disconnect there and you get off track and then you fall behind. And if you fall behind by a single day in the summer, if that day is a lecture day, a single day is, you're basically going to fail at that point. Very, very few students ever prove me wrong on that one. You fall behind just a little bit. So this 2 days in the summer, and it's bad news. So this 2 days might seem strict, and yeah, it is. Summer's fast. Like it has to be strict to make sure you're on a successful path. But that's the reasoning behind it. So each time you finish a task by the expected deadline, you earn an application objective. So you do all 8 tasks when I expect you to do them, or get ahead, watch the lectures, and do them ahead of time. That's already a B+. You already got yourself a B+ right there, just for doing something that you already have to do. Remember, you have to complete all 8 programming tasks to pass the class. If you do them in a timely manner when I'm expecting you to do them, and dare I say when you're supposed to do them, that's already a B+ with 8 AOs, 8 application objectives. If you don't complete the task in 2 days, you might be thinking, oh, he said I have to finish them to pass the class, but he's only giving me 2 days. What the hell? That's where the final deadline comes in. The final deadline is your last chance to complete the task. It's basically a free extension on every assignment. Since the grading structure is so unforgiving that you just miss one of these, you automatically fail. And sometimes there's just a task that hits you wrong, and it's just not clicking, and you're never going to finish it in 2 days. And that's fine as long as you're putting in your effort and trying your damnedest to hit this deadline. Sometimes you're just going to miss it. It happens. So for that, the final deadline, which is at midnight, 11 days after the material was introduced in task. So basically a 9-day extension, more than a week extra to work on the task to finish it before you fail the course. If you're 11 days behind and you haven't completed that task yet, then it's just F in the course. Nobody's coming back from 11 days behind in the summer session. It's not happening. You're not proving me wrong on that one. Nobody's proving me wrong on that. So that's where I set the final deadline, because nobody's been able, without the final deadline, I used to have final deadline all at the last day of classes. Nobody's come back from 11 days. Nobody's come back from, I forget the numbers, but I want to say 7 days. Like no one a week behind is coming back. So I give this pretty generous, I think, 11 days, because if you're actually needing any of these final deadlines, you're failing the course no matter what. Whether I officially say that you failed or if you have false hope, I give you false hope and say, oh, you can keep going with the class. Like, you're not coming back from that. It's not happening. So do not rely on these final deadlines unless you plan on retaking the course in the fall. But I do want to give a pretty generous 11 days, even though I don't think that's recoverable. If it takes you 10 days to complete an assignment, I don't think that's recoverable. But I want to give the 11 days just to kind of put it out there that, hey, I'm not being too strict with this grading policy. It's just if you can't do it in this time frame, like you're going to fail anyway. So it's less pressure with the learning objective grading and the mastery-based grading, that knowing that you have that 11 days. But I mean, I'm not a believer that you can go to a final deadline and come back. No one last summer who submitted on the day of a final deadline passed the class. Especially the ones who on task 1 they're already using the final deadline. They all failed. Every one of them failed. So don't do this, but I do offer this lifeline just in case, because sometimes, something, you can get like the first 5 tasks great, and then, I don't know, you get sick, you're just ill for a week or something, you fall a little behind, but you're strong enough of a student that you can get caught back up. I still want to give you that lifeline and not just say, well, 2 days, you're done. But 2 days, given that you're focusing on this class, presumably in the summer, 116 has much more of your focus than it does in a fall or spring where you're taking like 5 or 6 courses. 2 days is basically a week in the summer. So with all that, the way I look at speaking of weeks, the way I look at the course is, the schedule of the course is that it's a Tuesday through Friday course. On Tuesday, you're learning some content. You're learning how to do the current task. And then Tuesday, you start the task. You work on the task. You hopefully finish it. But realistically, at least starting the task, you get a good night's sleep. You wake up Wednesday, and then Wednesday, you're doing that task. That's what you're doing, is that task until it's done. And then Thursday, lecture time again. You learn how to do the following task. You start that task on Thursday, get some good night's sleep, work on it Friday, work on it till it's done. And then after that task is done on Friday, you met both expected deadlines in that strat. And then Saturday, Sunday, Monday, 3-day weekend. Every weekend's a 3-day weekend. And just relax for 3 days. Don't think about 116 too much or at all, depending on what you're doing. And then next Tuesday, do it again, another 4-day rush, and keep doing Tuesday through Friday. That's how I view the course. I told the TAs to prioritize Wednesday and Friday office hours, because that's when I expect most of you to be working on the current programming tasks. So Wednesday and Friday, hopefully Miriam gets her office hours and puts them on Wednesday and Friday, and we'll get some good coverage. We have Matthew has a few Monday office hours. I don't expect those to get too much traffic, except for students who are behind, because you're only working on final deadlines at that point. So they should be more chill office hours for students who are desperately trying to get caught back up, or students who are getting ahead, of course, too. All right, so that's the 8 programming tasks expected, application objectives, and there's 4 more for the quizzes. This one's a lot simpler to explain. There are 4 traces on the midterm, 4 traces on the final exam. For every trace on the midterm that you complete, that you get a pass on, that's an application objective, 1-to-1. This is my way of encouraging you to take the midterm. I don't want to see anybody having to take the final exam. If you're going into the final exam needing any traces, either in OP, data structures, or both, that's stressful. Your whole semester is on the line going into that exam, and you have to pass some traces to get there. I know, historically, statistically, a lot of you will be taking the final exam, but I don't want to see any of you going through that stress. So my way of incentivizing the midterm is, 1, if you do well on the midterm, if you pass 1 of each on the midterm, you don't have to take the final exam. That's a pretty good incentive, I think, already. An optional final exam, hell yeah, sign me up. But also application objectives. You can earn application objectives on the midterm. So even if you think you taken the first OP trace and you think you crushed it, you're like, I got the learning objective locked up right now. You still do want to do that second trace so you can potentially earn 2 application objectives on the midterm, up to 4 if you're getting all 4 of the traces. Final exam, just like the final deadlines, it's your last chance to pass the class, but I'm not giving you any application objectives if you needed to show up to the final exam. Also, there's no reason to show up to the final exam if you already got your LOs. There's no more AOs available for you. So if you study well for the midterm, you get you go in there and crush 4 of those for all 4 of the traces, and then on the deadlines, you're doing your deadlines, working your ass off trying to get all these expected deadlines met. But things happen, and some of the assignments just don't hit you the right way, and you miss 2 of the expected deadlines, but you get 6 of them. You're still getting your A. And I won't go through every scenario. You can figure out what all the implications are. But that's how you're earning your A in this course. And the way this works, I'm giving you these AOs just for doing what you're supposed to do, what you have to do already in order to pass the class. Just doing it in a timely manner, staying up to date on the course. Summer moves fast, falling behind is a good way to fail. I'm incentivizing you to stay up to date on the material. I'm incentivizing you to study for that midterm and take it seriously. When you have 2 chances like that, students like to blow off the first chance and just rely on the last one. It's not something I ever recommend, but that's what most students will do in reality. So I'm incentivizing you to take that midterm exam seriously, even though it's your first chance to do everything. There's a lot of incentive here. So, take the course seriously, do what you're supposed to do, and do it on time. And you're probably walking away with an A. If you start missing some expected deadlines, yeah, the A is slipping away, but usually you're just going to fall the way to an F if you're missing some expected deadlines, because you're falling behind in the course and you're not going to catch back up. And I don't say that to scare. I want to scare you a little bit. I want to scare you all enough that you're going to take the deadline seriously and really try to hit the expected deadlines. But I say that because I genuinely don't want to see you fail. I want to see you go on to 220 and 250 and have successful careers. It's why I'm here, is to help you start your careers. So I don't want to see you fall into a trap where you're failing courses or passing this course and then failing next semester. I don't want to see any of that crap. I want to see you all get A's. And the way this ends up working is usually the grading is pretty bimodal. Most students either get an A or get an F. There's not a whole lot going on in the C- to A- range. You either do everything on time or you fall a little bit behind and get an F. It's the way the grading rolls out every semester. When I look at final grades, I just looked at final grades for the spring semester. It was mostly A's and F's with a little bit of each of the other grades. And that's why I incentivize staying up to date on everything. And I'm fine with it being that way. It basically turns into a pass-fail class. Fall behind and you fail, stay up to date and you get an A. Okay, no textbook for the course. Some links if you need them, if you want them. Academic integrity, don't cheat. I'm not going to belabor the don't cheat talk too much, but a few of them I want to highlight. Artificial intelligence obviously is on the rise. I'm sure you're all aware of that. It's something I watch for. It's something me and my colleagues are all getting better at spotting and everything. So don't use AI and don't submit coursework that isn't your own. These two combined, I have this clause down here where I can challenge your code at any time. So if I suspect that you submitted something for a task that you did not write, that wasn't your own work, I might call you in, I'll send you an email, call you in for a Zoom meeting, you'll schedule a meeting, and I'll pull up your code and ask you to explain your code, and you have to explain it enough to convince me that you were, in fact, the author of that code. So if you did actually write the code, that'll be no big deal. If you wrote your own code, this is something you never have to worry about. Even if you do happen to get called in, you'll just be like, oh yeah, this is my code, I did this, I did that, blah, blah, blah. And I'll say, oh, cool, thanks, have a nice day. But if you didn't write your code, you're going to have a tougher time. And you have to convince me that you did actually write that code. So whether it was AI, I'm not going to sit there and say, this is AI, I ran this tool and it said it was AI. I'm not going to do any of that crap. I'm going to look at it, and if I think it's AI, I'm just going to ask you to explain the code. If you can't explain the code, I don't care if it was AI or if you paid somebody to write that code or had your friend write it for you. I don't care what the situation actually was. If you can't explain your own code, I'm convinced you weren't the author of it. then it's going to be academic integrity, no matter what the reality of where that code came from was. Maybe you did write it and you just kind of blindly whacked the keyboard until Autolab spit out a 1. I don't know. If you can't explain your code, you didn't complete the learning objective, so it should be an F in the course anyway. And this is less popular now that AI is a thing. But working with another student to write your code, this used to be the most common form of cheating, is two students would work on an assignment together, either sitting next to each other, or in the summer, maybe they go in a Zoom call or a Discord call or something, and work on the assignment together. And when they both submit their code is extremely similar because they did it together. Even though there wasn't any code actually shared between the two students, if your code is looking extremely similar to another student's, I'm going to use that similarity to say, look, you didn't both write this code independently, and that's going to be an F for both of the students involved. And I'm not going to do this clause in that situation. If there's the old-fashioned, you submitted the same code as another student, that's just an easy F for both students, because if one student wrote the code and shared it with another student, the student who wrote the code can meet this challenge, but they still cheated because they helped someone else cheat, which is kind of the drug dealer versus the druggie analogy. Like, I want to go after the dealer. If you gave your code to somebody else, you're the drug dealer, and in my opinion, that's a worse offense than the person you helped cheat. You did a much worse thing by enabling the cheater to feed their addiction and keep them addicted to cheating. It's much, much worse. So I don't give a shit if you can explain your code if you're helping somebody else cheat, whether you just gave them your code or you sat down next to them and helped them write their code. I don't care what the logistics were. If your code looks very similar to somebody else in the class, 2 Fs. Easy. And every violation is an F in the course. And I won't go through the rest of them. You can read them on your own. But those are the 3 big ones. These are the 3 that cause the vast majority of students to fail if they're cheating, if they're AI. Okay, enough of that. Let's get to some course content. I got 2 more things I want to say. I forgot what they are, but I knew in the first lecture there were 2 things. I remember. It's my recommended strat. First, my recommended strat. So if you go through, the rest of the course website is the course schedule. And once you read the syllabus, you know everything that's in here. You can collapse this, and if you refresh the page, you come back, it'll stay collapsed. So, and then you can just uncollapse it whenever you need to refer back to it. So the rest of the page is the course schedule, which includes all of the programming tasks. Here's programming task 1. It's all right here in its entirety. The autograder is live on Autolab. Everything's ready for all the tasks all the way through task 8. All of them are live. You have everything that you need for the whole semester, and all the deadlines are listed. All the deadlines are also in Autolab. All the deadlines are here. So you know when everything is due, you know what you need to do. You have the autograders for everything. Everything is set up that you can do the entire course, or at least all of the programming assignments, right now. Everything's out there. There's nothing stopping you from doing these programming tasks, because all of them are released. And just to tie everything back together, you have the old lectures from previous semesters. So the first one, if you're hearing me right now, unless you're watching on the VOD, whatever. If you're hearing my voice, you don't have to watch the old ones because you're watching the new one. But right after you watch this one, you can go right to lecture 2, watch lecture 2, then right to lecture 3. After lecture 3, and the assignments are listed on the lecture that covers the last piece of content that you need for that task. So after you watch lecture 3, you can do programming task 1, submit to Autolab, get your credit for programming task 1, go watch lecture 4. That covers everything you need for programming task 2. Do programming task 2, submit that till it's done. Then watch lecture 3 on linked lists. Watch the linked list lecture, do the linked list programming test, complete that, and just keep going through the whole course. There's nothing stopping you from going through the entire course this week. There's not enough time to do it today, or else I'd say you could do the whole thing today. You could do the whole thing this week. By the time I'm doing another live lecture on Thursday, you could be done with all 8 programming tests. Now, that'd be a monumental feat to actually complete all 8 tasks. Unless, you know all the concepts already. You already, maybe you took AP Java, you already know polymorphism and inheritance, and you just got to fill in a few gaps and stuff. Well, there's more than a few gaps, but it's possible. At least by next Tuesday, if you just dedicated, you said, for the next week, my life is 116, you could complete all 8 programming tasks by next week. You have to have some good talent and a strong understanding of the 115 concepts and some other things for that to line up exactly. But everything from my end is there. Everything is there for you to just plow through the course. So that's my recommended strat. In fact, if you're trying to speed run 116 this summer, maybe you only want to spend a week and then you want to spend the rest of your time actually enjoying summer. You watch the lectures, do the tasks, and just go through the old lectures and do the tasks that way. You can also wait for the live lectures and watch the live ones, especially if you want to take advantage of chat. But that's my speedrun strat. That's the strat for speedrun is go through the old videos, go through the tasks right now. Nothing's stopping you from doing all that. The only thing you would have to do if you speedrun the tasks, you do have to wait for the midterm. The midterm and final exam will be at your scheduled time. It's the one thing you have to be live, like at the right time for. You can't watch any VODs for. Is the midterm on June 24th at the start of your lecture time. So for you it would be 11 a.m. unless you're in the, actually, that's my next point. I don't care which section you're scheduled for except for exam days. So if you want to go to the 8 a.m. lectures, that's fine. If you want to go to the 11 a.m. lectures, that's fine. If you want to go to both, that's fine too. But June 24th, you'd have to wait for the midterm, get my email, do the 4 quizzes, knock them out. Then you're done. That's it. You don't have to do anything else after that. Oh, I do have, I meant to double check this. I do have one typo in the learning objectives. Polymorphism will not be on the traces either. So in the read portion of OOP, polymorphism shouldn't be listed there. So polymorphism shows up after the midterm. Just logistically, I can't, the midterm would be too late if I added polymorphism to it. Which means I'll leave polymorphism off of the final exam as well, just to keep it consistent. So that's my speedrun strat. The last thing before we get into content, so much talking, we haven't even gotten into Java yet, is that there are 2 lectures. This was in my email. Let me just briefly recap. The first one's 8 a.m. to 10:30 a.m. This one is 11 a.m. to 1:30 p.m. All times are Eastern Standard Time. And I don't care which one you go to. Whatever you're scheduled for. Or if you don't go to either and you're watching the VODs from last summer and getting ahead on things, preferably, then if you already know the content, there's no real reason to come to the live lectures unless you just want to chat. Which you're more than welcome to do. And the teaching style I use for each lecture is going to be different. I mentioned this, I alluded to this in my welcome email, but I didn't give any details, so let me explain it now. In the 8 a.m. lecture, I'm going to teach off of the slides. You'll see all these slides linked here. 8 a.m. lecture, I'm going to teach off of the slides and just do my usual thing. If you're familiar with the fall and spring semesters, is probably hopefully the last time I'll mention that. I teach off the slides, and then very occasionally I'll have some live coding, and there are some live coding sections like Java examples and binary tree examples. Whenever it's examples, that's going to be live coding by design. And I will go to the tracing tool and do those live traces in the 8 a.m. In the 11 a.m., so this lecture every day, I'm going to teach a bit different. I'm going to use the Paul style. If you don't know what that means, just don't worry about it. But I'm going to do live coding, and I'm going to try to use no slides at all. So I'm not going to go into these slides right now. Instead, I'm going to go into IntelliJ and just do live coding and explain everything as I code. So there are 2 reasons for this. One is to give you 2 different teaching styles. so you have both of them available to you. That if one of them works better for you, like you can start off watching both lectures, decide which one works better for you, then go to that one. Or if you already know your learning style, you like more coding examples, or you like more concepts covered in the slides, you can go to that lecture or watch the VODs for that lecture. If the 11 a.m. time frame works for you, but the 8 a.m. lecturing style works better for you, at 11 a.m. pull up the 8 a.m. VOD. Old, it'll be 3 hours old at that point. Pull up the 8 a.m. VOD and watch the 8 a.m. lecture at 11 a.m. You have that option, and not quite vice versa, but you have options there. And 2 is just for my own sanity. If I'm doing the same thing like that twice in a row, it drives me nuts. It's not too bad in the other semesters when it's 50 minutes, but when it's 2.5 hours of doing something, then 2.5 hours of doing the same exact thing, I'm going to go absolutely insane. So 2 big reasons to do different styles, because it's just more interesting for me to do, to keep myself thinking, so I'm not just regurgitating the same stuff. Like this first hour is kind of tough because I just said all of these exact same things, not exact, but all of these same things. But now I get to switch it up and do something different finally. So with that, I want to do intro to Java, and I'm gonna cheat a little bit. I'm gonna pull up the. Wait, do I even have to cheat? I don't even have to cheat, do I? But I'm gonna cover what's in these slides in live coding, and I probably, just based on how far I got in the other lecture, I probably won't get too far into the loops and conditionals content. But next lecture is designed like that second Friday in the other semesters. It's catch-up day. So, and we usually have Labor Day in here, and the spring starts on a Wednesday. So we have 4 lectures of content over 6 lectures of time. So we have time to get caught up on Thursday. So I probably should just move loops and conditionals to Thursday, since that's the way it's going to end up happening every single time. So with that, let's start some content. Let's do it. And the end result is going to be in the repo already, but I'm going to delete this one. I'll start from scratch and write all the code from scratch without relying on what's already there. So first, this is IntelliJ. I didn't get to do an IntelliJ demo in the other lecture because I just jumped right to the slides, and I might do it Thursday. But this is IntelliJ. You can go to the links on the course website and go to IntelliJ and download IntelliJ. I always recommend IntelliJ Ultimate. It has a bunch of features that we won't really need in 116, but I recommend it just because there's features you might want for side projects and for future courses and for future stuff, even though you won't need them this semester. You can get this for free with an educational license, which you can get because you have a .edu email address, or you can just stick with Community Edition, which is free for everybody forever. And use the Community Edition. For what it's worth, I'm actually using the Community Edition this semester. Usually I use the Ultimate Edition because that's what's installed on my laptop, but I only use this machine for streaming, and I'm only using it, like I haven't used it since last summer for streaming this course, honestly. And I did a full reinstall of Windows. I wiped everything on the device recently for reasons that are dumb. But then when I was reinstalling IntelliJ, I decided to do Community Edition just as a proof of concept that Community Edition does everything you need for 116. So once you install it, there's a little bit of setup. I wonder if I can break my setup just to show you. Yeah, I can break it. SDK, no SDK. So when you first write some code, we're going to write our first class. I have this source directory, Ooh, I don't think I like that one click. Open directory is a single click. I gotta turn that off. That's driving me nuts already. Okay. Oops. Well, we'll get rid of those right squiggles. So when we create... or do I do a clone? I'll save the cloning for another day. We don't need to dive into that. It's day one. We need to cover Hello World. But once we have everything set up, we have this source directory, src, for source code. And I have this package week 1, or this directory week 1. And I want to create a new class. I want to create a program that's just going to say Hello World. It's going to print Hello World to the screen, and I'm going to call it Hello World. And it's going to create my class for me. I get a few things here. I get a package declaration, and I get a class that we're creating. So I have a class. I think we can make this a little bigger. Usually I'm doing this on a projector and I need it, way bigger. But I think I do want it at least a little bit bigger, even while streaming. Go to 15. Yeah, that's good. By the way, I forgot my... for using resources like Geeks and Geeks, can we cite code? It's a fine line there. If it's large pieces of code, like you can't just steal a bunch of code from the website and say, I got this from Geeks for Geeks. But if you're using an example to learn from and you're afraid that your code looks too similar to the example, then you can cite it and say, this is where I learned this concept from, and if it looks similar to that, that's why. But you do have to learn how the code works. So if you just cite, like if you paste a bunch of code from websites and say, here are all my references, and I can still call you in and say, okay, great, explain this code. And you're like, I can't explain it. I just got it from these websites. That's an AI. That's academic integrity. That's enough, because you stole code. You didn't know how it worked or anything. But if you learn from a site and your code just ends up looking close to it and you cite it, the citation doesn't really matter, to be honest. You still have to understand your code, but you can cite it and let me know, hey, I did use this as a study resource. That's fine. Oh, sorry, Negril, I missed your chat. When are we tested for writing programs? Are we required to write our own tests? You are required to write your own tests for every, is that true? Every one of them? Yeah, every programming task. You will be writing your own test. So thanks for asking this too, because I forgot. There's something I wanted to mention. So task 1, it's the unit testing task. It's a unit testing task, so it's all about writing unit tests. But it does have you write 3 methods and write tests for those methods. So after today's lecture, they might be a little tough. Some of digits maybe. Actually, all these will be a little tough after today's. But after Thursday's lecture, you can write all 3 of these methods. But we still won't have covered unit testing until next Tuesday. So when we're going through this week, the Java basics, you can start writing the methods themselves and then write the tests next week, which usually I recommend writing the tests first before the code. But in this case, when you don't know how to write tests yet, and I'm saying don't fall behind, you're eager to get started, you can start writing the methods first. Both average and best key use data structures. We haven't talked about any data structures, not until Thursday. But sum of digits doesn't use any data structures, but it is a little tricky one. But you can start writing the methods, even if you're not doing the testing. And of course, I recommend just getting ahead on lectures and then learning how testing works and then writing the tests. Okay, so when I created that, I got a class named Hello World with a package declaration week 1. So the package declaration, let's start with this. Package declaration week 1 means that this code lives in the package week 1. In Java, the packages directly correlate one-to-one with the directory structure. So what this means is that this code lives in a directory named week 1, and I can see it in the directory week 1 right here. All of the code is in the source directory, src here, and it'll be src for the project as well. All of the code is in the source directory, so within the source directory, the package tells you where to find that code, week 1. And then when I created a class named Hello World, the class name directly corresponds with the file name. The extensions aren't shown here, but this is helloworld.java. So Hello World, the class Hello World is defined in the file named helloworld.java, and I can find it in directory week 1 because that's the package. So when you're looking at any Java code, the combination of the package and the class name is going to tell you everything you need to know about where to find that code, which is helpful when I'm doing lecture examples. Doesn't really apply, I guess, in the 11 a.m. lecture because I'll be in IntelliJ anyway. But if you're reviewing the slides and the example shows the package declaration and the class name, you know exactly where in the class examples repo, you know exactly where to find that example based on the package is the directory and then the class name. So if I'm doing characters and it's package week 5, you know exactly that this is where that code lives. So it is a helpful thing. And Java will enforce both those things. If I change this w to a lowercase w, I get an error because the class name no longer follows the package the class name no longer follows the file name. So I can either change the file name or I can change my class name. As long as they match, Java's happy. Same with the package declaration. If I call this week 13, I'm going to get an error because Java does enforce that structure, which is nice because you always know where to find the code that you're looking at. How to create a new directory. So say I want a subdirectory in week 1. I'll go new package, week 1 stuff. Or if I decide I'm going to make a week 15, I'll right click on source, new package, week 15. To create that. And a class, I'm going to ignore the word public for now. Yeah, I'm going to ignore the word public for now. But a class is something we're going to talk about extensively next Thursday. And I'm going to say that a lot in today's lecture. There's a lot of things that I kind of had to just kind of gloss over for now because they're all very deep topics that we're going to spend a lot of time later talking about. Class we'll talk about next Thursday. For now, what we need to know about classes is that all of your code in Java must be contained in a class. So we're creating a class, we're naming it Hello World, and then we have these 2 braces, and everything in between those braces is the class definition. It's everything about that class. It's all the code for that class. All of your code that does anything in Java has to be contained in a class. It absolutely must be contained inside of a class. So we need a class to just do anything. So that's why classes are related to files. This Hello World file is the Hello World class, and all the code for it is inside that class. So right from day 1, this very first example in Java, we have to talk about classes. So only 2 things that go outside classes: package declarations and import statements. We won't see import statements until Thursday. The first one we'll see is importing an array list. It looks like that. Other than package declarations and import statements, everything will be contained inside a class. For those of you who've seen Java before, for those of you who haven't, just ignore the next thing I'm about to say. Those of you who've seen Java before, I will say everything has to be in a class. Yes, it can be an abstract class, which I can't type correctly. It can be an abstract class or it can be an interface. Those are both allowed as well. That's perfectly fine. And Java, IntelliJ even changed my symbol here to interface. Oh, I changed when I reinstalled Windows, I lost my key configuration. But for now, I'm just going to say everything has to be a class, because that's all we're going to see for quite a while, until polymorphism week, where everything's going to be a class. So everything has to be in a class. It's technically incorrect, but it's correct enough for what we're doing right now. What was I just going to... Oh, I never really introduced IntelliJ, but IntelliJ is the program we'll use to write Java code. It's an IDE, an integrated development environment, meaning it's a text editor and and a Java compiler. It has everything we need to be able to run, edit, and just work with Java code. Even a debugger, something that I absolutely love that I'll talk about. I'll have examples of as we go throughout the semester. And it's an environment that's just set up for Java code. I just said that, didn't I? So there's IDEs for different languages, and IntelliJ is one that's fine-tuned for Java development. That's what its job is to help us write Java code. All right, so let's write some Java code. We got our class. We're ready to write some code, and I'm going to write my first method. Yes, that's right, method. Let's get the definition out here. I'm going to just type this out, and then I'll explain each thing here. I'm going to do a public static void. Oh, it's weird typing this whole thing out. String array args, and then my braces. Oh my goodness. And then my braces. So this is our first method in Java. So I'm saying method. To you, it might look like a function. There is an important difference between methods and functions that, again, we'll get into later next Thursday. The difference between a method and a function for now is a method is what would be a function that lives inside of a class. So since everything in Java lives in a class, we don't have any functions at all. We only have methods because all of our would-be functions are inside classes, therefore they are methods. The subtle difference between the two we'll get into, like I said, next Thursday. But for now, when I say method, everything you know about functions translates into methods as well. They have names, they have parameter lists, they can be called by giving them argument lists, they can have return values. All that stuff applies. All of that is the same, except I'll say method because I want to be technically correct. I don't want to tell you incorrect information. So these are methods. I'm going to call them methods. But when I say method, if you hear function in your head, if you just associate methods as functions, I'm fine with that. It's technically incorrect, but at this point, you don't even know the difference between the two, so it doesn't matter to you at this point. And then we'll straighten it out next Thursday. Okay, so I have a main method, and a main method is going to be your entry point into your program. So when I run Hello World, when I run this class, what it actually does is runs the main method. So we need a main method. If we're going to write a Java program, somewhere in that program we need a main method, or else we can't run anything. There's just no entry point to our program. A main method has to be exactly public static void main with a string array as argument. So let's go through each one of these. I'm going to, again, actually, let me not skip public. I'm trying to go in the same order as my slides, but I don't need to do that. We can be more open-ended in this with this style. I think that's why Paul likes teaching in this style. He can pivot whenever he needs to. So public means that this code can be called from anywhere. So if I want to call this code from one of my other classes in my code, I'm allowed to do that because it's all public. And a main method has to be public, and your classes have to be public because that's how your program is going to start. When I start Hello World, that's being called by IntelliJ, by Java. That's happening from outside of the class. So it needs to be able to access this class so it can access the main method, and the main method has to be public so it can access that. If we have either of these as private, that's not going to work. Where you can see some changes, probably a little early to explain all the changes, but I can't run this program anymore. It's not going to be able to run. I don't have any run button. But if I undo that, now I have a run button. I can actually execute this code. I can run this code now. But I can't do that if I don't have a main method, and if the main method's private, technically I have a main method, but it can't be accessed from outside of the class, so I can't call the method. I can't run my program. Because private, as opposed to public, private means that this code, this method in this case, can only be accessed from within this class. So any code in between these two braces, that's part of the class. Any code in here can call the method, but any code outside of this class cannot, which means nobody can call my main method because the main method has to be started from outside of the class. So your main method has to be public. And for now, until next Thursday, again, actually, everything is going to be public. We're not going to worry about this. This is called an access modifier, controlling who's allowed to access this code. We're not going to worry about it for now. And another nice thing of doing live coding is I can test stuff. I don't know what happens if you have a private class. It means your code can't be accessed at all, and there's no reason to ever have a private class if it's a top-level class of a file. But I wonder if it'll give me an error. It does give me an error. Good, because it should give me an error. Something I had never tried, because why would you ever do that? But I was wondering what Java would do. Modifier private not allowed here. Good. I want that error. I want that to exist, because there's no reason to ever do that. Next, static. Static means that this code can be called without any extra work. The extra work we're going to see again next Thursday. There's a lot of stuff that comes next Thursday. The extra work we're going to see is creating objects of the class type that you're writing. So creating objects of type hello world and then calling the method through the object. We don't even know what objects are right now, so that's not something we're messing with. So we're going to make these static so we don't have to do that to call the method. Static methods are called through the class itself. So when you, and all of your methods for now are going to be public static, with one exception on next Tuesday, and then after next Thursday, pretty much none of them are going to be static. And but for now, we're going to call our methods through the class. So for your problem set for your task 1, when you write your testing, you're going to write problem set the class dot average dot sum of digits dot best key. You're going to call those methods through the problem set class without having to create an object of type problem set. So we'll talk about objects when they come, but right now we're calling things through the class. And static is basically a way for us to pretend that our methods are functions. So it's an easier transition from 115, where you did functions, into methods, because static just basically doesn't care that they're methods. They're practically not methods. They're literally methods, but they're practically not. And then we're finally ready to write some damn code here. So let's do hello world. To print something to the screen in Java, and if you haven't caught on yet, Java is, even to write the simplest program in Java, which is what we're doing right now, it's quite a bit going on. Oh, no, we're not ready for that. I didn't do void. Void means this method doesn't return anything. We're going to talk about return types in the next example in a bit more depth, so I'm really glossing over this one. Main, your main method needs to be called main, M-A-I-N, all lowercase. If I capitalize this M, I no longer have a main method. That's not what main methods are named. They're named lowercase M-A-I-N. So if you don't have that name, you're not a main method. Main method has to take a string array as an argument. This is something we'll talk about, what anything is going on here. Arrays actually is something we're not going to talk about this semester. It comes up one time very briefly, and then I just pretend it doesn't exist, basically. You'll see when we get there, but I quickly turn it into an array list so we don't have to talk about arrays. But the rest of this, we'll talk about in the next example. And then args is a variable name. To have a main method, all of these things must be exactly like this. It has to be public, static, void, named main, and take a string array as a parameter. The only thing that can change a little bit is args. We usually use args just by convention. That's what IntelliJ will fill in for me in a minute. But this is a variable name, so if I want to call this arguments, because that's what it's short for, that's perfectly fine. That's the only thing that can change. But typically we do args just by convention. That's what everybody calls it. Just stick to the convention, and your code's going to be more legible to other people. If I saw arguments, that just sticks out to me. I've never seen a main method like that. It's always called args. The string array args is something we're not gonna use. I lost my train of thought for a second. It's something we're not going to use in CSE116. This is if you're using command line arguments and calling your method through the command line. This is where those arguments would go. It's not something we're messing with in 116, so this is something we're mostly going to ignore, except for right now. This is the only time I really talk about it. This is something we're going to ignore throughout the semester. So your main method has to be public static void main string array args. And that's a lot to remember. And we have a big old IDE that's set up for Java, right? So we have a lot of little tips and tricks and shortcuts and stuff. One of them, once you understand what all that stuff is for the main method, IntelliJ's got your back. You can type main and enter, and it's going to fill it all in for you, and it is going to call that args, because why not? That's what you should call it, and give you your main method. So you don't really have to memorize, this kind of boilerplate code that's going to be in every single program. We don't need to spend too much time memorizing it. You should understand this. Like, again, if I sat you down and said, what does public static void main string array mean? You should be able to explain it. But I wouldn't expect too much depth. And if you sat down to type it and you're sitting there thinking, wait, was it public void static or was it public static void? We don't need to waste brain power thinking about that kind of stuff these days. There's a lot of other stuff to learn. We don't need to get bogged down on the details. Okay, now we're ready to actually write some damn code that does some stuff. And we're going to write something that prints to the screen. And it has to be more complex, because then this is what I was starting to say earlier. If you haven't noticed yet, things are a lot more complex in Java, even for the simplest program, including printing to the screen. It's system.out.println, and then the string that you want to print. Oh, it's hard for me to even type that. And then in the slides, I do hello Java. This is going to print hello Java to the screen, system.out.println, and then every line in Java any statement ends in a semicolon. So it's yelling at me to put my semicolon in here. This used to be a big deal, back in the day. This used to be a big deal. We had to track down our missing semicolons, and our programs would break and give us really cryptic, crappy error messages. Things are a lot easier these days. IntelliJ has it a red underline, a red squiggle right there for me. If I try to run this program, it's going to tell me missing semicolon on line 6. On line 6, position 42, so this must be 41 characters of code. At character 42, it was expecting semicolon on line 6 and semicolon expected. Very easy to fix those. So it's not really that big of a deal for getting semicolons, because we have so much tooling to just help us out, which, it's debatable, better or worse. Makes for sloppier programmers, and then that catches up to you when you're doing the more complex stuff. I'm not getting into the whole debate right now, but IntelliJ is going to find those missing semicolons for you. And then we're finally ready to run the program. We can do this in quite a few different ways. We can use this run button here, or my favorite, right-clicking the file and using this run button here. And then it prints hello Java to the screen, and everything worked great. And I tried breaking this earlier. That break didn't happen. I think it auto-fixed it. I think I clicked something that accidentally fixed it. But if you see this, when you first install IntelliJ, you should see Project JDK is not defined, setup SDK. You should see something like this. I'm going to set up my SDK. It'll give you some options. You might not have any options here. I downloaded a few JDKs already, so it has some for me. If you don't have any options here, do download JDK, and whatever it recommends, you don't have to change any settings here. I always make sure the course works for the latest, whatever IntelliJ works by default at the beginning of that semester, which used to be, these lower numbers. We're on 24 now, apparently. I thought we were still on 22, or I think 23 last semester. So we're on 24 now. Click download, and then give it a second. You'll have a progress bar down here. Once that ends, all the errors should go away. My run button should come back any minute, and there it goes. My run buttons come back, and now I can run. We got another progress bar. So I switched JDK, so this is probably going to take a second. Actually, no, it already ran. It said indexing. I knew it was indexing. All right, so that's our first example in Java. which is not very simple. And I mean, last semester it was print hello Python. And we'd say, this is how you print things to the screen. Okay, next example. We're done with that one. I mean, a little more than that since it's 115. It's the first code you've ever seen. But that's the entire file is just print hello Python. In Java, not so much. It's all of this. It's all of this stuff. But now that we know the structure of a program in Java, we can actually write some Java code. And I'm actually going to do none of those. I'm going to create my own. It's going to be variables, functions, but I'll call it something different so I don't have a name conflict. I'll call it functions variables. It's a dumb name, but anyway. So when you create a new class, again, IntelliJ's filling out the package declaration and the class name for me. No choices to make there, no thinking that needs to be done. And then and we want to create our first variables and functions. So I need a main method first, and I want to declare a variable. Sounds pretty simple, right? I know. But there's a lot we got to talk about with this. So we're just talking about functions and variables and function. I say functions, but methods. Variables and methods here. So the first couple of learning objectives in CSE115. And I mostly just want to focus on the syntax of Java. You already know what variables are. You already know what functions are. You already know what conditionals, loops, data structures. You know all this stuff already. You know the concepts. And I just have to show you how to do it in Java, which is just talking about the syntax. But there are some Java concepts that don't come up, at least in Python. If you're coming from another university and you've done, say, C++ or Java, obviously if you've done Java, all this is review for you. But if you're coming from something like C++ or even C, this won't be entirely new. But coming from Python, or if for some reason you had a CS1 in JavaScript, if you're coming from those languages which are dynamically typed, you're going to come to Java and notice that Java is strongly typed. So we have to have our 2.5, yes. So we have to have a type with every single variable we create. So in Python, this would just be number equals 2.5. If I do that in Java, I get an error. And it's going to say your variable needs a type. Cannot resolve symbol number. It doesn't even give a meaningful error message, because why would you be writing Java code without types on your variables? You need a type on your variable. When I create a variable, so I'm not just saying create a variable named number and assign it the value 2.5. That's what we did in Python. Now we also need a type when we declare a variable. Now in Python, you could kind of muddy up variable declaration versus variable reassignment, but the difference between the two is very important in Java. When you declare a variable, you must specify the type of that variable, and when you reassign a variable, so say I reassign this to another number, 6.3, then I do not specify the type. You only specify the type once. If I specify it twice, I get an error. Redeclaration of a variable is what that should say. It's not what it literally says. But I can't, it's trying to redeclare a variable with the same name as a variable I already declared. You can't have two variables with the same name. It's not allowed. So you declare the variable one time and then reassign it. Specify the type when you declare the variable. The type of a variable, what this means is that this variable is not just a variable named number that gets the value 2.5. It is a variable named number of type double, which means this variable can only ever store a double, where a double is a numeric value that can have a decimal portion. So my 2.5 is a double, and number can only ever store a double since I declared it as type double. So this is what we mean by strong typing. Every single variable in Java must have a type. And this type for this variable is going to be double, which is our floating point value. There's also another type called float. Oh, I forgot. You have to put the F here. It's so annoying. That's why I don't use floats. Floats are the same thing, but they're a 32-bit precision. If you're wondering, like, double, that doesn't make sense at all. Why don't they call it number or something? They call it double because we used to have floats, which are floating point values. The float actually means that it can have a decimal portion. And floats were 32 bits. And then when they came out with doubles, they said, hey, let's do the same thing, but let's make them 64 bits. So it's double the precision of a float, but for some reason they just called them doubles. And the name kind of loses what it actually is. But it's a double precision floating value is why they call them doubles. It's weird, but it's the way it works. It's the way it is. And we have other types. Let's go through the types first. I can deviate from my slides here. Let's create another variable, int x, and give it 7. So an int is an integer value. This must be a whole number. So when I create my value, my variable for x, I have to assign a whole number. If I do 7.1, this is going to be a double, and I can't put a double in an int. An int can only ever store, a variable type int can only ever store an int. Just like my number, say if I try to assign this number, this double to a string, that's not going to work either. I can't make that assignment. It's not going to work for me. It's going to say required double provided string. You can't put a string into a double. It's not going to work. So I can't put this floating point value into my int, my double into an int, even if the decimal is 0. The int has to be a whole number, but it also has to be in the format of an int. So int x equals 7 is fine. Oh, and I forgot one thing to talk about in the last example. System.out.println is annoying. It can't just be print because Java has to be verbose about everything. But again, IntelliJ has us covered. If we do s out, it's going to print it for us. It's going to type all that for us. So we don't actually have to type all that main method stuff. I'll do in hello world. So like if I was actually coding and I wanted to for some reason type hello world, main s out hello Java. Like it's going to take me no time to actually write that method. So all that boilerplate, we do have some shortcuts to take care of it. And then x, if I want to print out the value of x, and then I can reassign x, but what I reassign it to has to be an int. And I can reassign it to something, say 9 divided by 5. Should have made the math a little easier on me. What's that? 1.8, right? But x is an int, and I told you ints have to be whole numbers. So what are we going to get here? I don't have any errors. Let's use this run button this time. So x equals 7 the first time, that's expected. X equals 1 the second time. 9 divided by 5 equals 1. Whew, boy. It's interesting. So what's happening here is that we're getting something called integer division. If we ever have two integers divided by each other, the result has to be an integer. So Java has to take this 1.8 and turn it into a whole number, an integer value, one way or another. And the way Java does that is it takes effectively the floor of that value. So this 1.8 turns into just 1. The 0.8 gets truncated, it just completely gets erased, and we get the value 1. So even though, so it doesn't round, it wouldn't round that up to it wouldn't round that up to, what am I trying to say? I can't type and talk at the same time, apparently. It won't round it up to 2. And in this case, like this, we would expect it to be pretty much 2. We have almost 2,000 divided by 1,000. It's going to be 1.999. To us, it's basically 2. But if we run this code, it's going to end up being 1. Actually, let me change this to a 2 just so it's a different result than the last one, or 5. So basically 6,000 divided by 1,000. It's basically 6. But when I run this, I'm going to get 5 because it's going to round down. It's always going to take the floor or truncation. So that 0.999 gets erased, and we just get the whole number portion of it. So it's effectively taking the quotient and throwing away the remainder and not calculating any decimal portion. Now, if we don't want that behavior, this only happens if you have an integer divided by an integer. So if I want to change this behavior, if I turn one of these values, let's do double y and print y. If I want to change this behavior, I'll make one of these a double just by putting 0.0. So it's the same math and everything, but now it's not integer division because it's not an int divided by an int. It's an int divided by a double. Now the result will be a double. I have to store it in a double because I can't store a double in an int. I'll get a type mismatch here. Since the result's a double, I need to store it in a double. And now I will have my decimal portion because doubles are allowed to have that decimal portion, and I get the correct result that I expect. But for the sake of example, I want to go back to integer division. So I'm going to go back to integer division. We can also have variables of type string. A string, I guess. I am a string. That's how we do strings. I don't have too much to say about strings. They work just like strings in any other language you've programmed in, except I guess C, which doesn't have strings. You have all kinds of methods available to you, and IntelliJ will give you all the suggestions of what you'd want. You can do, it actually doesn't. You can do length of a string. You can do split is something we'll use later in the semester. All the methods that you would expect to have. Char at, which in Python would be just your array index brackets. In Java, it's char, the method char at, and then the index. Just all the methods that you would expect to have in a string. They're all there. It's a sequence of characters. That's a string. In Boolean, bool equals true. I don't have anything to say about Booleans. They're Booleans. If you made it through any CS1 course without learning about Booleans, your instructor didn't do their job. You have to learn about Booleans. You ain't going to talk about conditionals without talking about Booleans first. So I don't really have anything to add to that, except it's lowercase t, lowercase f in Java. Other than that, they're Booleans. And notice out of these 4 types, and we'll get a lot of mileage out of just these 4 types, double, int, string, and Boolean. And notice that string is the only one that has a capital S. Also, it's highlighted as white instead of orange like the rest of them. Strings are a bit different than the other ones. We're not going to worry about it too much. I'll talk about the difference in a later lecture when it's more relevant. But string is a class, which we can go to the string class. It is a class. And then we are actually dealing with an object of type string. And the rest of these are values. These are primitive types, which are stored by value. And we'll talk about references. Actually, that we'll talk about on this Thursday. But we'll get into all that. We'll talk about all of it. But strings are a little bit different. They're special. But we're actually going to pretend that they're primitives. We'll get into all of that, but not today. Today, we want to finish this up with functions and then a memory diagram. So let's create a function. So I'm going to create a public. So meaning this function can be called, this method, I'm saying function because I'm looking at the word right here. This method can be called from anywhere. It doesn't have to be from within this class. For this example, it could actually be private, but I don't feel like talking about private anymore today. We'll talk about that again next Thursday. Next Thursday has a lot of juicy topics. And static, again, we don't want to have to create objects at this point. We just want to create very simple methods that basically behave like functions, so we're going to make them static. And from this point forward, all of my methods for this week are going to be public and static. So I'm going to stop highlighting it every single time. They're just going to be public and static for a while. And I'm not going to talk about it again until we see something that's either not public or not static. Then I'll highlight that again. Then the next thing I'm going to have, and what I want to do, by the way, is I want to create a method that multiplies the input by 5. That's all I want to do. Just some really simple method, just so we can talk about the way methods are structured. So let's get the whole thing. Let's call it times 5. Let's get the whole thing out there because I can't stand looking at all the red squiggles, all the errors and everything. So let's get rid of all the errors, and then I'll come back and talk about what we got here. So I'm going to have a parameter input of type double. I'm going to create another variable just because I want to talk about variables. We're going to call it x equals input times 5.0 and then return x. So what I have here is a return type. We just talked about types. We saw 4 different types, and we saw that every single variable in Java must have a type, and we specify that type when we first declare the variable. In addition to that, methods must have return types. This is specifying which type the method will return. So when we call this method, and method calls work how you would expect from any other language, we're going to have, I'm going to do number equals times 5 number. So I'm going to call the method, and when this method call resolves, when this expression resolves, it will resolve to a value of the type of the return type of the method. So this is my, oh, it actually says contract right there. This is my contract. This is your contract with Java. When you set a return type for a method, you are saying this method resolves to a value or returns a value of this type 100% of the time, and Java will hold you to that. When you specify the return type, that's a guarantee, 100% guarantee you're returning a value of that type, with one exception later in the course. There's always exceptions to everything. But we're going to return a value, just to make it not an exception, we'll return a value that can be stored in a variable of that type. That's 100%. And I'm specifying double, so I have to return a double. In this case, it's a primitive, so it will always 100% return a double. No question at all. But once we get into classes, it gets a little different because you can return null if anybody knows what I'm talking about. But we have to return a value of double. We're returning x here, and x is a variable that I specified as type double. So this is going to be a legal return, and I've satisfied my contract with Java. If I say return some string, that's going to give me an error because that's not a double. Required double, provided string. Very clear error message. I returned the wrong thing. Can't have that. We can't do that. So I have return x. That's of type double. Everything's fine now. So that's your return type. You must always, always, always return a value of that type. Then the method name. That's just like any other language. We have the method name. Can I get these to stop popping up? Show on mouse, move. Let's turn both of these off. That's so much better. All right, the method name, don't have anything to talk about with that. lower camel case, so the first letter should be lowercase, and then each start of a new word should be capitalized. Which I always mean I should stress coding style more, because I don't know, I don't at all now, and even TAs have terrible coding style. But some of them, not all of them. But lost my train of thought again. It's a lot of lecturing is my defense. I'm at hour 4.5 of lecturing, almost all straight. So we have a parameter of named input. Now in Python, it would just be this. This would be your parameter list. In Java, every variable has a type. Parameters are variables. So your parameters also have to have types. So this method takes a parameter of type double and returns a double. So when we call this method, we better give it a double. And if we're doing anything with its return value, we better be storing it in a variable of type double, which we are. All of our things line up. So we're doing good there. So double takes an input, and then the body of the method is more familiar to any other language. We have strong typing again, so this new variable we declare needs to be a double, because we're multiplying two doubles. That's going to result in a double. We have to store it in a double. Then we're going to return our double to satisfy our contract. So we call our method, number gets a new value, then we're going to s out number. And for all the trouble that is caused by, I shouldn't say trouble, but by strong typing, all the things we have to think about with strong typing, which is a huge benefit of Java, by the way. At first, it might not feel like it. All the strong typing, it requires more thinking. Thinking's hard. But it does lead to less buggy code and much fewer errors, and much less often having your code crash. Your code's going to be a lot more robust with the strong typing. Because without strong typing, you might have this be double, and then number might be of type string, and you won't know, like if this were Python, you wouldn't know that until you ran your code and got to that line of code, and then your program crashes once you get to that line of code. So with the strong typing, your Java is constantly checking your work as you go and letting you know, like, hey, I think you might have an issue over here. You should look into that before your program explodes. So it's really got our backs and helping us write less buggy code, which is always a good thing. So for as finicky as Java is with the strong typing, it actually is a little less finicky in certain things compared to Python. And can I not? Just don't show toolbar. And this is one of those cases where it's less finicky than Python. In Python, this here would be an error. I'm concatenating a string with a double, or which would be a float in Python, would be called a float in Python. And in Python, this will give you an error. It would say can't concatenate string and float. And then you go, oh man, for the 100th time. And then you have to do this, str of number, convert that to a string, and then concatenate the two strings. And Java doesn't make us do that. Java will auto-convert. It'll say, oh, you're concatenating a string and literally anything else. You can concatenate anything with a string in Java. But in this case, a double. It's going to convert that double to a string for us and then concatenate. And the same thing, I forgot to mention it up here. This is the first time we used it. Both of these cases, it's converting our ints into strings and then concatenating it to the string without forcing us to do that extra step that Python makes us do. So one real nicety in Java. And let's do one more method. And we're going to be ready for some tracing. Public static, because they're all public static right now, but now void is the thing I want to talk about. We've seen this with the main method, but I didn't talk about it until now. I'm going to call this y because it's called y in the slides. Let's have this take an int. I'm going to name this int x, because why not? Because I want to use x 3 times, so I can make another point later. And then S out. Why would you do this? And then I want to call this method, and we'll call it with, it has to be X. So this method, every method has to have a return type, period. Has to have a return type. But some methods that you write, you're not writing the methods to return anything. Like for methods like this that are crunching numbers and just doing some math, this clearly returns a value because you have some input, you're doing some mathematical operations, and then you're returning the result of that. So I'm calling this method for the result. I'm calling it for its return value. But that's not always the case. Sometimes we call methods for what we call side effects. Sometimes we call a method that has some effect that's not related to a return value. In this case, our side effect is printing to the screen, but we don't need this method to return anything. In that case, we set the return type to void because every method needs a return type, but a return type can be void, which means this method doesn't actually return anything, just returns nothing. And then we don't have any return statement in this method, just like the main method. The main method was void. We don't call main methods to return anything. We call them for the side effect of running the entire program. And we don't have any return statement at the end of our main to just because there's no reason to return anything at the end of main. If you've written any C or C++ code, you do return an int from your main methods, which is the status code to the operating system to let it know what happened with the execution of that program. Java doesn't do anything like that, it just doesn't return anything for the main method. This method doesn't, I call it why because why does this method exist? You would never actually write this method. You would do, you would just put this code down here. Well, maybe there's some conceivable reasons you would write a method like this. But same with the times 5. You wouldn't do this. You would just say number times 5 down here. But we want simple methods for our first methods, for our first example. So I can get rid of my comment here. The code's self-commenting now. And that hits everything I want to talk about. Oh, we didn't run this. Let's run it. Make sure the output makes sense. So x equals 7 we looked at. We just assign x the value 7. X is 7. We had integer division here. So x was 5. X was updated to the value 5. We have a few variables. Times 5, and then printing number again. Number is 31.5, which should be 6.3 times 5. I'm not going to double check the math, but I trust the computer. And when we called y, we got why would you do this printed to the screen, and then the program ends. So that's our first Java program. Any questions on this? Since there's live chat, I'm going to stop many fewer times to ask for questions. In a live lecture, if somebody wants to do the old-fashioned raise their hand and stuff, I want to stop for lectures to give them a chance. But with live chat, just at any time, I could be mid-sentence. You can just post your question in chat and ask. But there haven't been questions for a while, so I'm getting a little concerned that I maybe should stop for a second here. Since 12:16, it's 45 minutes ago was our last question. If y'all don't ask questions, I can just say, hey, go watch last summer's lectures, and I'll take a break. The reason to do lectures still is for questions, so I want your questions. Oh, I forgot to... Here, I get used to streaming again, though. My face was blocking some stuff. I want to open a terminal, I think. Is there any allowance for citing code like Geek for Geeks? I know I asked for questions, but I don't want that one. I'm sorry. I answered your question pretty extensively. Like, I felt like I spent too much time answering your question last time. If you're going to ask a question, you got to at least listen for the answer. I'll give you a short answer. I mean, cite your code, but it doesn't really matter. You have to understand your code anyway, because if I challenge you for your code, if I call you in and say explain this code, your explanation can't be I used Geeks for Geeks. That can't be your answer. So you can cite it to show me where you got the code from, but you still have to understand it. So if you're using that site to learn how to code, and then you're worried that your code is going to look similar to that example, and you're worried about it getting flagged, you can cite it just to cite it. But you have to know how that code works. You can't just steal someone else's code and submit it for your own work. So how do I... Yeah, no problem. Yeah, and if my answer, if you did listen to the first answer and it just wasn't satisfying to you, please ask for clarification. But just asking the question again had me wondering. All right, I was messing around with this, just trying to get it the way I wanted it to while I was waiting for some questions, but I'll have to mess with that between lectures. I want to get something here. I'll mess with it offline. There's no time to talk about random stuff. Okay. This was the tab I used for that example. Oh, I navigated away. Trace practice. Java. So I just took the code that... Oh, son of a bitch. I did copy instead of paste. Copy, Alt-Tab, paste. There we go. Gonna hide toolbar. We're going to full screen. And resize this down. Okay. Oh, message retracted. I wonder what it said. I'll never know. Okay, so let's do our first trace. And for those of you who've seen traces before, some of this will be review, but some of you haven't. Some of you didn't take 115 at UB. So I want to make sure I start at the top and explain everything that's going on with tracing right from the top. Now I'll go through it fairly quickly, because even if you've never seen this tracing tool before, any CSE CS1 course at any university, you should understand these concepts. They should have covered these concepts. Even if they didn't cover it in exactly this way, they should have made sure that you understand these concepts. So I really got to explain how we represent things in our tracing tool like this. Again, this is the tool that you'll be using for the quizzes. It'll be exactly like this. You'll get some code that we give you. I'll email you the links to the 4 traces when it's midterm and final exam time, and you'll have basically this exact interface. There'll be the menu here. You might not be in full screen, etc., but it'll be this same exact setup where you'll have the code here and then your 3 sections, stack, heap, and IO. And you have to trace through the code. I'm going to do exactly what you would do if you were to see this code as one of the traces for a quiz. You wouldn't see this code because this isn't testing any of the learning objectives. It's not objects, inheritance, polymorphism. Polymorphism I explained earlier is not on there. It's not classes, inheritance, linked list, or trees. So this wouldn't be a quiz that you get. But if this were, this is the same structure. I'm going to do the same exact thing that you would do. So let's start tracing this. So tracing this, we're going to start with the stack. Every method call creates a stack frame. Every Java program starts with a method call of the main method. So every single Java program, every single trace you'll do all semester is going to start with a new stack frame for the main method. Stack frames are isolated environments for that method call, and any variables inside the stack frame can only be accessed during the execution of that method. So when I have the main method and any variables in the main method, they can only be accessed from inside the main method. And I'll talk about that a little more when we get to our first other method call. Whenever we create a variable inside a stack frame. So I have a variable that's going to be declared. What we're doing is keeping track of how the computer organizes its memory, and it organizes it into stack and heap like this. Heap we won't use at all today, so we're just focusing on the stack today. The stack is where the computer is going to store all of the variables that are currently in memory. So when I declare a new variable, this variable number, I'm going to store it in the stack with its name and its value. Its name is number, and its value that it's assigned is 2.5. If you've never seen this before, like, that's it. That's the magic of it. We're going to store all of the variables that are currently in this method call through its stack frame. And then this variable is reassigned. Number is assigned the value 6.3. When we update a variable's name value in our memory diagrams, we do not just change the value here. What we're going to do is use this plus sign. We're going to cross out the old value and type in the new value. Our goal with these memory diagrams is that at the end, once we're done with the entire thing, what we have is a complete trace of everything that the machine did when it executed our program. Everything it wrote down, everything it changed, everything, every single step that it took. We'll have a complete history of the execution of the entire program. And that's what we're doing to assess if you can read through code, is if you can tell us every single thing that the machine did when it went through the code, we know that you can fully read the code. You understand what happens when your code is executed by the computer. Is a stack frame temporarily stored similar to Python would? It disappeared after execution function returned in the main. Yes. In our memory diagrams, you'll see once we get to the end of the ×5 call, we won't literally erase them from the trace because we do want the history of everything. Actually, I'll show you right here. We're going to cross them out instead. So we're going to cross out the stack frames when they return, but that is the way we're representing that it was deleted by the computer. So yeah, stack frames are temporary. When we get to the end of the main method is erased from memory, and the whole program is just gone. Everything's gone. All right, and next variable is x. X is 7, and right now I think is the good a time as any. We do technically have the variable args. This is in the main stack frame. It is the first variable that's in here. But since this is something we never use in 116, we will just skip tracing args at all. It is technically on the stack, and it's a reference to an object on the heap, which is an empty array. But we're just not gonna mess with that. It's gonna clutter up every single memory trace that we do, and for no benefit. So we're just gonna skip it. It's fine, but technically it is there. If you run the debugger in IntelliJ, when we run that, we'll see that args is actually in the main stack frame. We're just not tracing it in 116. And we get to our first print statement. When we do print statements, we represent those in the IO section. So the IO, X, and then we need to resolve the value of X right here. And this is the first of many times I'm going to recommend this. When you need to resolve a variable to a value when you're doing a trace, do not look at the code, look at the stack. So I'm going to take X and I'm going to do exactly what the computer does. I'm going to look at the stack. I'm going to go in my name column, look for X, and then look at the value that it's storing at this moment, which is 7, and then put my 7 right here. I'm not going to look at the code because I have, it's going to be opening up the opportunity to make mistakes. Now in this case, int was just assigned the value 7. I'm not going to make a mistake right here. That's kind of silly. But in the 2 lines from now, I might. So the next line, X gets reassigned the value 5. So I'm going to cross out 7 and type in 5. Because this is integer division, the result is 5.999. The 9.999 gets truncated. We only get the whole number portion when we have integer division, the division between 2 integers. If I have any decimal points here, I'll get a different behavior. But I have no decimal points. These are 2 integers divided by each other. I get integer division. I only get the whole number, or effectively the floor of the quotient. So X is 5 now, and now I'm going to print X to the screen again. X, which I know is going to be 5, because I just just evaluated it. But we always look this up in the stack. X is currently 5, so that's what's printed to the screen. And this is where it's easier to make a mistake. You might say, oh, what's X? You scan through your code. Oh, X is 7. And you print 7 to the screen again. Don't let yourself make dumb mistakes like that. Like, it's a dumb mistake because there's no reason to make it, because you have the answer that you literally wrote down right here. Just look over at the stack and figure and get your value for X. So if you're looking through the code, even if you do spot this, you're going to say X equals 7. Oh, but X was updated here. But what's 5999 divided by 1,000? What is the integer division? No, you already did all that work. Don't duplicate your work. Don't evaluate everything twice. The computer sure as hell ain't doing that. You shouldn't have to do it either. Go over to your stack, look up the value. It's 5, 5. Zero thinking. The computer don't think at all. The computer has 0 IQ, and it can do this. You can do this, just don't overthink it, and this is the first of many times I'll recommend this. One of my big hints for tracing is don't overthink things. A lot of times students get into trouble by overthinking things on the trace or trying to predict things or guess what's going to happen. Just blindly go through line by line and do what the code tells you, and exactly what the code tells you and only what the code tells you. And when you need to look up a variable, just blindly look it up in the stack. Don't overthink it. Too many students have even failed the course by overthinking these memory traces. And then a string, another variable declaration. I know it's a declaration because it has a type. If there's no type, it's a reassignment. If there's a type, it's a declaration. Whenever it's a declaration, I got a new variable on the stack. So in the main stack frame, a string has the value I'm a string. And for what it's worth, I would never care about this on a quiz, but a string, actually a few things. Let me take chat first. In Python, all the functions are considered objects. Would these methods count as objects? I don't know exactly how to answer this one. I'm not 100% on this answer, so take it with a grain of salt. But the methods would not be objects. Oh, it's even more complicated because they're static methods. Because somewhere in here an object has to happen. I think there's an object of type class, and they're called through the class object, I believe is what's happening. Which is just all kinds of confusing. When we get to non-static methods, the methods will be called through an object of the type, and it'll be more clear that they're being called through an object that's on the heap. But I think that's how it works. The class loader creates objects of type class, and they're called through that object. But that's not something that'll affect anything in 116. It won't affect our behavior here. So are the methods, are they just attributes? You can think of them as attributes, yeah. We'll also have we'll have like private int y equals 7, which are more directly correlated with attributes. But if you think of the methods as attributes of the class as well, I think you'd be doing okay with that as your mental model. Yeah, if that's your mental model, that the class is the object and the methods are attributes, which it's one way of looking at them, yeah. Anyone else listening, if you don't want to think about it like that, yeah, you don't have to, please. But that is one way you could look at it. Okay, a couple things here. I forgot to mention, but in our traces, like even though I made a big deal and Java makes a big deal about the types of every variable we ever create, all these types all over the place, in our traces, we will never put down I can't say that, that's not true. But we don't have types on any of our variables. We'll have types on our classes when we get to that. But we don't have any types on any of our variables in our memory traces. Because we just kind of don't care. But we do have ways of representing our values to know what the types are. Like this is 6.3. I know that's a double. This is 5 with no decimal portion. That's going to be an int. If this were a double, I would have put 5.0 here to know. And then our strings are going to be in quotes. So like if I had a string with the value that's just the number 5, I would put that in quotes so I still know that this is a string on the stack. When we print things to the screen, we don't use any quotes here. They're not printed with quotes. When it's printed to the screen, everything's a string, so there's really no need to distinguish. But also, when you print things to the screen, like when we were in IntelliJ, nothing was surrounded by quotes when it's actually printed to the screen. So just to be accurate to what's actually displayed when we run the program, we don't put quotes. And then bool true. Bool true. And true looks like a string, but it's not in quotes, so I know this is a Boolean. That lets us distinguish between a string that has the value true and a Boolean that has the value true. The string will be in quotes, the Boolean will not. And then we get to our first method call besides our main method. But also the types don't matter. This is something we have to be beyond lecture 1 to really fully appreciate this, but the types don't matter in our traces. In memory, we don't care what all the types are. In our code, we do, and in memory, we don't. For reasons. By the end of the semester, that will make more sense. With 9 minutes left, I got to finish this trace. So we have a new stack. We have a method call. Every method call is associated with a stack frame. So we have a stack frame, and the name of the frame is the name of the method that's being called. And when we have parameters of our method, aside from args that we ignored, our parameter is going to be the first thing in the stack, in this new stack frame. So input, which is going to be assigned the value of the argument. And the argument, we have a variable number here, which is an expression that resolves to a value. So we need to figure out what value this resolves to. We're in the main stack frame resolving the variable number. So we go to the main stack frame, look for the variable number, and it has the value 6.3. I actually did forget where that 6.3 came from. I can look back at the code and figure it out, but I'm not doing that. I'm doing what the computer does and just looking up the value here. So it resolves to 6.3. We send 6.3 to the method call, and input gets the value 6.3. And we're ready to trace through the method call. Now we have a new stack frame. We have 2 stack frames on the stack right now. The stack frame where we're currently executing, that's the only stack frame that's active right now, and we can only read the variables inside this stack frame. We cannot read any of these variables from the main stack frame. And one reason why this is important is when I declare this variable x and assign it to input times 5. Oh, I knew I was going to set myself up to have to do math during lecture here. When we have a new variable we're declaring named x, input, let's just do the math, 30, 15, 30, 31.5, I hope. And now I'm declaring this variable x inside this stack frame. Now we already have a variable x in the main stack frame, so I can have another variable x in the same stack frame. So you can't reuse variable names, but if you're in a different stack frame, it's a completely isolated environment, so I can reuse my variable names as much as I want, which is a very nice feature to have. That when you're calling, like I'm calling the print line method, I know it has a parameter because I'm giving it an argument, and that argument's going to be stored in some parameter, some variable with some name. And I don't have to care what name println uses for that. It uses something, but I don't have to care what it is because it's going to be in a separate stack frame, a completely isolated environment from all of my code. If that was not the case, every time you called a method like this, you would have to worry about what they named their parameter, what local variables they declared, and what they named those. And you have to cross all those variable names off your list of variable names that you're allowed to use. So the fact that stack frames are isolated environments like this and that you can reuse variable names, like you might just say, well, I just won't reuse variable names. QED, problem solved. Well, yeah, but you're calling methods that you didn't write also, and you don't want to have to care what they named all of their variables so you can avoid reusing those names. We don't want to do any of that. So it's really nice that stack frames do exist, that method calls are in isolated environments called stack frames. It's a very nice thing to have. Right now I have access to input and x, and that's it. And x is 31.5, not an int with the value 5. It's a double with the value 31.5. And we return x. Oh, every single time I forget this. Times 5 returns to the variable number. So we're going to set our return arrow in the tracing tool to say that this is going to return to the variable number. And then when we return x, we cross out the stack frame. When a method ends, and a return statement will end the method, when a method ends, its corresponding stack frame is destroyed. It's removed from memory. It's completely erased. Yes, I am Professor Jesse. What's up, Atika? That stack frame is removed. Input and x, these two variables, are removed from memory. Hi, Negro. And this stack frame is deleted. In our traces, we indicate that by crossing it out. It is actually removed from memory, but we indicate that by crossing it out because we want to preserve the history and remember what happened with that stack frame. So we just cross it out. And in return 31.5, we're going to update this variable. We don't just change the value. We cross it out and update with 31.5 again because we want to preserve history and remember everything that happened during the execution of this program. And then we're ready to move on to the next line here. We're going to print number, and then number, we're going to look it up, 31.5. It's really easy to get that one wrong. You're going to have number, it's reassigned, that's reassigned again. Yeah, you might put 2.5 or 6.3 or no. You look at the stack, 31.5, get the right number. Don't do any extra work. Then we're on our next line, another method call. We have this y, because why would you ever write this method? Y has a parameter x, so I'm reusing that variable name x again. It's even getting the value of an x, but this x is in the main stack frame with the value 5, and I'm sending that to the other x in this other stack frame, give it the value 5, and then execute this method. So again, I have x 3 times in 3 different stack frames. It's perfectly allowed. It's perfectly fine. In fact, a lot of the methods in the math library, if I do math.absoluteValue, I'm pretty sure that uses the variable x. I don't have to care because it's a different stack frame. Who cares? It's in a different stack frame. So it's really nice that stack frames are isolated. Hopefully I sold that point to you. And then this, why would you do this? Let's print to the screen. Why would you do this? Because why would you write this method? It doesn't really make any sense. And then this method ends. A void method. So void methods, by the way, can have return statements. If you just want to end the method, say you're in a loop and you have a conditional in a loop, and if that condition is true, you want to return, just end the entire method. Something you want to do sometimes. And if you have like a find method in a data structure, as soon as you find the value, just return it right away, for example. You can just do returns, just return semicolon with no value that you're returning. Or you can just let the method end by hitting the closing brace. And that's what I'm doing in this case. We hit the closing brace, the method ends, there's no return arrow because nothing's being returned. And that method's removed from memory, which we indicate with by crossing it out. Then we reach the end of the main method. Main method is crossed out, and that's the end of our program. Once we hit the closing brace of main, that program is over. And what we're left with after the end of the trace is the complete history, everything that happened during the execution of this program. Now, in reality, when this program runs, at this point, we hit the closing brace, there's nothing on the stack. The stack is completely empty. There's nothing there at all. But we're only indicating that with crossing it out, so we can look through this and see everything that did happen, especially when grading. Of course, this is an academic environment. When you submit your quiz, if every single quiz you submit is just an empty stack, what's there to grade? So we want to see the whole history to make sure that you do understand how to read through this code so we can properly assess you to see if you've completed the learning objective. So there's a little bit of an academic curve to this, but we want to see all of the history, every variable update that you did, all the return arrows, all the stack frames, everything that happened throughout the execution. If we didn't, then all we have to go off of is what's printed to the screen. And at that point, we might as well just give you code and say what's printed when this program executes. And then if you type like 31.6 instead of 31.5, we have to go, well, it's not what's printed to the screen, so F in the course. Like, we don't want to do that. What we want to do is have all the information available to us. So if you make little mathematical mistakes, like if this, like I'm not 100% sure I did the math right here. I think I did, but if this isn't actually 31.5, you can go through my trace and see that I did make the method call the way that I expected. I got the right input, and then I can see the disconnect would be from input to X, where this value just isn't this value times 3. And then I know that you just made a simple mathematical error, which I'm not grading you on in this course, so I can easily give you a pass as long as everything after that works with the value 31.5, even if that's the wrong value. If you use that value in the right way and clearly just made a simple math mistake and everything else is correct given that mistake, it's still an easy pass. I can say, okay, you demonstrated classes, inheritance, linked lists, trees, you're good. That list does not contain multiplying by 5 or simple mathematics or any other little mistake. You can make a lot of little mistakes and still pass a quiz as long as you demonstrate an understanding of the concept that's being assessed, the OOP and the data structures concepts. That's what we're looking for. Okay, and we're out of time. I like starting on time and ending on time. I don't want to just go over. It'd be easy to just go over and say, well, we still got to do loops and conditionals. Let's just keep going. No, I'm not going to do that to you. So loops and conditionals and data structures, we should easily be able to fit both of these in on Thursday and still do some examples. So that's what we'll do. We'll start loops and conditionals on Thursday. All right, thanks for the kind words, Jason. Later, would hash maps and arrays in the heap, and where would the loops be incremented in? Loops will be, I'll quickly answer you here. Loops will be in code blocks. So we'll create a code block and have the iteration variables here. And heap, yes, array lists and hash maps will be in the heap as objects. We'll see both of those on Thursday, actually. We'll see both of those concepts. All right. So I have office hours in half an hour. So if you do have questions for me, 2 o'clock, I'll be in this Zoom meeting. Happily answering your questions and helping you out with any questions you may have. Until then, I'm going to catch my breath for half an hour, and then I'll see y'all in there. All right. Take care, everyone. Take care. I love that name, Thickless. Imposter sus. I am pretty sus to you. I think you're a TA, I believe. All right. See y'all Thursday.